Hey everyone, welcome back to the channel Code with AKJ. Today is day 29 of solving Geeks for Geeks problem of the day. Today's question is mirror tree. So the question says given a binary tree, convert it into its mirror. So first, what is the mirror of a binary tree? So in simple terms, you need to swap the left and right subtrees of each and every node. So for example, for node 1, we need to swap the left subtree of it and right subtree of it, and we'll swap it with each other. So for node 2, the left subtree which is 5 and right subtree which is 4, we need to swap it. So in this way, for each and every node, we need to swap its left subtree and right subtree to convert a given binary tree into its mirror. So the brute force approach here is simple but involves recursive swapping at each node. So the idea here is to recursively call the function for left and right subtree and swap them at each and every level. So let's visualize the recursion. So we'll start at the root node here. We'll recursively go down to its left subtree and we'll recursively go down to its right subtree, and until or unless we'll find a null node, we'll go down and finally we'll swap the left and right children. So here in this case, let's dry run this using recursive call. So we'll start from root node 1 and we'll go recursively to its left, and again we'll go recursively to its left. Here we found null node, so we'll return from this function call. We'll again go to its right, we find null node, so we'll return from here. So two nulls from two calls, so the subtrees would remain same. So from here we'll return back to the main root which gives 3 here. So again from this root node we'll give a call to the right call. Well, again from here we'll give a left call, and left call we'll get two nulls from 5 node, and from 5 we'll return 5 value here, and from 2 we'll give a right call, and from right call we'll give a left call and right call which gives two nulls, and from here we'll return 4 here. So for node 2, the left call value would be 5 and right call value would be 4. So we'll swap this. So after swapping, the subtree would become 2, 4 and 5, and we'll return this whole right subtree to the root node for its right call. So here it will return 2, 4 and 5. So for node 1, what we'll get is left call would be 3 and right call would give us a subtree whose root would be 2. So we'll swap these two things, and finally our binary tree, after giving recursive calls, would convert it in its mirror image. So our finally binary tree would look like this, where the left subtree and right subtree get swapped with each other. So here the time complexity would be O of n, as we are testing each node at each level, and the space complexity would be O of n as we are using recursive call stack. So let's try to code this approach and let's see whether it gets accepted or not. So this is the code for the brute force approach we have discussed. Here the base case would be if we found any null node, we'll return from there and we'll give a left call and right call for each node, and finally we'll swap its values. So let's try to compile and run. It's okay, so let's submit. As you can see, this problem got solved successfully, so the time complexity and space complexity would remain same. So let's try to optimize this approach a little bit further, or we can use a iterative approach which can handle large set of trees. So now let's optimize this a bit. The recursive approach is already optimal in terms of time complexity, but we can avoid the recursion by using an iterative approach with a queue. This eliminates the recursive overhead and help us manage larger trees more efficiently. So here the of using queue would be like this. So first we'll take the root node and we'll swap its left and right children. So we'll swap 3 and 2. So the tree converts in this way, where 2 and 3 are being swapped, and we'll push these values inside our queue. We'll again swap the front element. So here it would be 2. The and again we'll swap its childrens, which would be 5 and 4. So after swapping 5 and 4, the tree looks like this, and we'll pop it from the queue and again push its childrens inside our queue. So queue looks like this 3, 4, 5, and we'll again pop the front element, which is 3 here. We need to swap its children since its children are null, so the tree remains same. Again queue goes like this 4 and 5. We'll pop the front element 4. We'll swap its children 4 and 5. In this case, the both are null. And in the same way, for the node value 5, we'll pop it from the queue and we'll swap its children, which is null as well. So in this way, with the help of using queue, we iteratively solved this binary tree and converted it into mirror tree. So it is more efficient comparing to the recursive approach we have discussed for the larger trees, as it handles larger trees efficiently. So here the time complexity would be O of n or O of height, and the space complexity would be O of n as well, as we are using external data structure Q here. So let's try to code this approach and let's submit. So here this is the code for the optimized approach we have discussed. Here if the root becomes null, we need to return from it. We have taken a queue of node star, we have pushed the root value inside it, and we'll run a loop until or unless queue becomes empty. We'll take the current node from the queue, we'll swap their children here using third variable temp, and we'll push the left child and right child of that current node inside our queue for further processing. So in this way, until or unless the queue becomes empty, we'll run this process, and after finishing our loop, our binary tree will convert it into its mirror tree. So let's compile and run this. So let's submit. As you can see, this problem also got accepted here. So the time complexity is still O of n, and space complexity in this case remains O of n due to the use of queue. However, the benefit is that it avoids recursive calls overhead, making it better for extremely deep trees where recursion could lead to stack overflow in some cases. So that's it for today's problem. We learned how to mirror a binary tree using both recursive and iterative approach. So if you found this video helpful, please don't forget to give it a thumbs up and subscribe to my channel for more coding tutorials. Also let me know in the comments which approach you prefer, recursive or iterative. So that's it. I'll see you in the next video. Thank you.